for this video, for my Chem 101 students, we will be doing the not so daunting task of determining mass number, number of protons, and number of neutrons for different isotopes. This is with regard to chapter 3, and this is homework number 51. So what you need to do this problem is you're going to need the periodic table handy. So actually, let me pull one up, but you should have one in your book. And all you got to do is pull up a periodic table and we're ready to boogie. So let's see. So one piece of information that we need is that mass number. We need to know that mass number, it's going to be a whole number. Why? Because it is the number of protons plus the number of neutrons, right? So mass numbers for certain isotopes are always going to be whole. So we see here that we have mass number of 60, so that must mean that this number plus this number must be 60. Easy peasy. And we must know that number of protons is the atomic number. So you cannot change this number. This is the number that shows up on the periodic table. And you cannot change number of protons or you will be changing the element, which I wish I could do to turn everything into gold, but that's alchemy. We can't do that. So with those two things in mind, we can identify for this first problem with nickel, they give me the mass number of nickel, but they don't give me the number of protons or the number of neutrons. Number of protons is the easiest. If you know the element, you can find the number of protons. If you know the number of protons, you can find the element. How? We use the periodic table. So I'm going to look up nickel on my periodic table. Nickel is abbreviated Ni, and it looks like it's number 28 on the periodic table. So what does that mean? It means that we have 28 protons, right? So number of neutrons must then be 60 minus 28, right? So that's 32. How did I know that? Because protons and neutrons must add up together to be the mass number. So this next one, we're not given the element, but we are given the protons. So all I have to do is look up what element has the number 46 on the periodic table, and it looks like palladium. Is our culprit here for this problem. So palladium is the element we're talking about here. So number of neutrons, how would I find it? I'd find it very much the exact same way. I would do 108 minus 46, right? And I will never do math in my head, even though everyone at home is probably screaming how easy that is. We have a number of 62 neutrons. So 62 plus 46 should equal 108. So that's a good way to check yourself. Next, very similar situation. We're given no element, but we are given the number of protons. So all I have to do is look up who has 7 protons on the periodic table, and it turns out to be our buddy nitrogen. So now that I know nitrogen is who we're talking about, the mass number is what? The mass number is mass of protons plus mass of neutrons. So it's going to be 7 plus 7, so my mass number is 14. This next one, we know iodine, but we don't know a number of protons. You see how these are the first two that I usually attack? Protons and number and name, you know, the identity of the element. That's usually the easiest ones to determine first because, hey, you already know that they're the same, right? They're interchangeable. So if I'm iodine, how many protons do I have? According to the periodic table, I have 53 protons. And then I know that mass number is protons plus neutrons, so it's going to be whatever 53 plus 74 is. Again, no math in the head. I don't want to risk anything. I get 127. So for bonus practice, why don't we go ahead and represent these? So we will represent the nickel. So you would do the elemental symbol, right? And then, so we would have nickel right here, which is the elemental symbol. And I'm just I was double checking that I'm representing it in the exact same way your book does, is that you have how they represent it is X, A, and Z. So X is the chemical symbol, or the elemental symbol, sorry, elemental chemistry symbol. A is the mass number, and Z is the atomic number, right? So for our first situation that we have, nickel, we would represent it as Ni because that's a symbol. And what's the mass number for this isotope? It's 60. And then what is the atomic number, which is the number of protons? 28. So that is how you'd represent that isotope for nickel. And we would call this nickel 60. That's how it would be named. Nickel, but with a mass of 60. Nickel with a mass number of 60. That's how you'd represent it. You guys ever hear of carbon-14 dating? Carbon, and then it'd be like a dash 14, right? So one more practice, why don't we do the nitrogen? So it would be the chemical symbol for nitrogen. Let's make ourselves a little spot here to practice. Chemical symbol for nitrogen, which is N, and then the mass number is on the top left here, and that would be 14, and then the atomic number or number of protons, which is 7. We would call this nitrogen 14, right? You've seen it written in the books a couple different ways, so we'd call this nitrogen 14. Alright guys, I hope that helped. That's how we tie in mass numbers, protons, and neutrons to represent different isotopes.